this. Okay. The drawing shows 4-point charges STUV located at the corner of this square with sides A. Which of the following statement is not true regarding the system? So they have given you a charge. They have not given you the charge type. Is it positive or negative? Okay. But they have given you the magnitude of this. This is 1, this is 2, 3, and 2. The electric force between the charge, they're talking about the force. Okay, so here they're talking about the Coulomb law. I'm not sure if you remember the Coulomb. Have you heard of Coulomb law before?
No, I haven't actually.
Okay, so Coulomb law is basically says force is equal to a proximity constant, that is vacuum basically, a constant number that you have to remember, Q1 multiplied by Q2 divided by d square, where d is the distance from the center of one charge to another. So in this particular kind of situation, you are dealing with two charges one at a time. Okay. The electric force between the charge S T is repulsive. S and T is repulsive. That is true because they're just saying Q, right? Q everywhere. So I'm assuming it's the same charge for all of them, which is Q. Plus or negative, doesn't matter. So if they are Q and Q, they're gonna repel each other in other direction. The magnitude of the electric force on U due to T is less than the magnitude of electric force on U due to V. That is not true. If you look at the formula here, the bigger the charge, the bigger the force. The bigger the distance, the smaller the force. So you need a smaller distance and bigger charge. Here, if you notice between U and T, the distance is X, which is bigger. X is greater than A. That means the force here will be bigger due to distance. And again, the magnitude here is Q, and here is 2Q. So the force applied by QFV, I'm going to clear this all because it looks like a mess. I'm going to draw a line, or actually an arrow. Now, this way. Okay, so it's getting repulsive. That's how it's moving. I'm going to clear this. Okay, so I'm going to write that now. There's the force. This force is induced by the charge V. This force is induced by the charge T. And this force is induced by the charge S. They're basically saying in the statement B that the force Ft is less than Fv, which is correct because the distance from here to here is bigger and the magnitude is smaller. So B is correct. The reason A is not correct is because they have not told you what is the charge for Q. Is it positive or negative? So you cannot talk about it. Okay. Now let's look at the C. The magnitude of the electric force V due to U. Now you're going to analyze at V. Okay. So I'm going to go at direction. I'm going to draw arrow. Again, the same direction. Same. This way and this way. And this direction is Fs because it is induced by the charge S in the straight line. This one is induced by Ft and this one is induced by Fu. Okay. And in the statement C, they're talking about the magnitude of the force on V due to U. Fu is greater than the magnitude of the force induced on V due to T. Ft. That's the comparison they're talking about in the statement. So two things you need to notice again: distance and the magnitude of the charge. The smaller distance, the bigger the force. The bigger the charge, the bigger the force. So Fu, you have magnitude 3 and you have distance A. So force is 3 and A. And in T, you have same distance, so same type of force, but you have a magnitude Q. That means the force Ft is going to be less than Fu, which is correct as well. They're talking about not true. Okay, so we're actually going backwards. So B is correct, C is correct. The net electric force on you due to the 3 other charges is 0. That is push, push, pull. That can be potentially wrong. The net electric force on T due to the 3 other charges directed out of the square. That is correct. So I'm going to assume that Q is the same charge, either positive or negative, because they have not mentioned, they just said Q. So it's going to be either positive or negative for all of them. So let's assume positive for all of them. Since they're all positive, they're going to be repulsive. That means the statement A is correct. Let's look at the statement E. The net electric force on T, they all are repelling T out of the square, out. So that is correct. The only statement that is not correct is D, which says the net electric force on due to the other charge is 0, which is not 0. This is pushing out, this is pushing out, and this is pushing out as well. By 0, it means that all the forces are balanced. Okay, which is only possible. I will show you a scenario. Imagine you have 3 charges here. This one is negative 2q, this one is positive 2q, and this one is plus 1q. This one is trying to attract. This one is, this is positive, right? Sorry, yeah. This is trying to repel, and this one is trying to attract. Actually, let's keep both positive. Okay, that means, yeah. Okay, let me erase this. Yep. Okay. Now, because our situation is all positive, if you notice, if you have one positive Q in the middle of 2 positive Q, this one is trying to push it that way. This one is trying to push it that way. That means it does not move because assuming that the distance between these two are the same, which is to us is A, and the magnitude number is the same. Okay. So here the answer is D. Now tell me, did you understand what I just said?
I'm actually listening to you and I have it recorded so I can review it later on.
You can review it later on. Do you have any issue with this one?
No, I don't have any issue at the moment. I'm just using
Okay,
it.
let's do one thing. Let's move on to next question. And okay, this is last one, right? So I will just put it down here that if we have time at the end, we come down to that. Okay, this one. Did you understand what I did here? Now there are a few fundamental I will explain, and I think then you can try by yourself.
Okay.
They're talking about electric force. Okay, that's called Coulomb's law, which is K Q Q. This is Q1, the first charge. This is Q2, the second charge, divided by D squared. Okay. This is an ideal situation in which you have only 2 charges. Here you have more than 2 in this particular question. D is basically the distance from the center of each charge. That's the D distance. And Q is the magnitude of the charge here and here Q2. Okay. Using this, based on the what sign they have, imagine if Q1 and Q2 are of the similar sign, positive or negative. Let's pick positive in a case. Then the force you will find using calculation method would be repulsive and would be pushing both charges outwards. Whereas if you have opposite sign, plus and negative, your answer would be forces that is attracting towards each other. Same value, but opposite directions. In this case, we have four of the charges. That means we have to deal with them one at a time. That's why I drew arrows at each charge. At each charge, you have three forces applied by three other charges. So here there's a force up, there's a left here, and then there's a diagonal here. Okay. The reason I'm saying three charges is because the other three charges are inducing force on the reference charge, or called the point charge. So if I'm analyzing in perspective to this charge, these three forces are generated because they are in line with the other charges. See, the A and this one, vertical. And these statements are based on those charges. Now I explained to you the formula. The bigger the charge magnitude, the bigger it would be the force. That means F would be increased if you increase the Q value of either one. F would also increase if you decrease the D value because it's at the bottom. In that perspective, if you solve this question, it is simple. Okay. Now you can review it with the recording again to understand what I said. It won't be hard. But what I can recommend is you searching square charges Coulomb forces. Okay, that's what I would recommend looking at Facebook or YouTube. Square charges in square. Sorry, square charges in square. Charges in square. Coulomb method. Coulomb force equation. If you type that in Google, you would be able to find much more relative examples and detailed explanations.
Okay.